Alright guys, listen up. You will have a cumulative test tomorrow. Elijah, my man, y'all listen. You will have a cumulative test tomorrow. It will cover what we've done up to this point. I will say I went through SchoolNet. I turned on or went into the schedule settings, so you should be able to access all of the previous tests. But I will say your Unit 1 test, when I got on a while ago, the image things, which is what I had to use to put in the equations, because they had knocked out the, it's called LaTeX, is how I did the equations and stuff, but the images for that seem to be wiped. I don't understand. I'm going to have to call those people, but you may not have a good copy of that test. You should be able to see the test itself and see what you missed on it, but you won't be able to see whatever equation was sitting there. So if you'll remind me in just a little bit, I'll try and remember, but I will go through and find my copy of the test booklet, the PDF file that I printed when I first did the test. Actually, I printed it to a file. I will post that on Google Classroom, and then you can cross-reference the questions from there. Okay? But I don't know what happened with that, but anyways, I'll have to talk to SchoolNet people about that, which I've already been talking to them about why I can't put equations in the way we did last year. And they've not been very helpful, so anyways. This is you guys. No, that's my copy. Alright. First thing, guys, we're going to look at the Unit 2 test and finish that out. We left off at number 11, which was the expected value problem.
We didn't go over it.
Do what? I didn't hear that. I'm sorry.
Probably went over 11 yet. We stopped at like 10.
Yeah, we stopped at 10. 10C, which is right here. And I guess I need to zoom in, correct? That's really great. It's not going to let me zoom on here. Can y'all read this? Do y'all have your copy on Google Classroom? You should. So can you pull it up on Google Classroom, because it's not going to let me zoom while I'm recording. Okay. But anyways, I can't help that. But you'll be able to see what I'm writing and stuff. It says you are to draw one card from a deck. If it is an ace, you win $10. If it is a face card, you win $1. Otherwise, you lose 50 cents. It says, what is the expected value of this game? Okay. What's the one thing we said on expected value that you have to set up before you work it?
Fairness.
Well, fairness is more a looking at the expected value itself. And we said if it's equal to 0, it's a fair game. But how do I get the... Hold on one second. Excuse me. Sure.
Okay, I'm done. Okay. Now you play.
Okay. Thank you. All right. Okay, guys. Back to the problem. The question was, how do I find expected value? And the goal is to set up your outcomes and your probabilities of those outcomes. Okay? So what I want to do is say my outcome of x, which is what? the event, and then I'm going to look at the probability of that event, okay? And if you look at this, it says what? If you draw an ace, and this is drawing one card from the deck, if it is an ace, you win $10, okay? How many aces are in the deck? Okay. There's 4 out of how many cards? 52. And what do I get if I draw an ace? How about a positive $10? Okay. Because I'm gaining money, so we're going to put that as a positive $10.
Was that you right next to X?
Do what?
That plus what? Like right next to X, plus what?
Plus a $10. Yeah, $10.
Plus $10.
Yeah.
I couldn't quite make it out.
Yeah, it's fine. I don't know why it won't let me zoom. That's really frustrating. But anyways, if it is a face card, how many face cards are in the deck?
13. 13.
No, that's of one suit. There's 13 in a suit. How many suits are there?
4. No, 3.
4 suits. Diamonds, hearts, clubs, and spades. Okay. And what else? How many face cards? There's a jack, a queen, and a king. So I have 3 types of face cards times 4 suits. So there's going to be 12 out of 52 possibilities. And then I'm going to win $1. So that's plus $1 if I draw a face card. And then the final outcome is what? That would be me drawing any other card, and I actually lose. So we're going to say you lose 50 cents. That's a negative 50 cents. And we're going to write that in terms of dollars because I don't want to mix units. Okay? And then what do I have? And the next problem, guys, I'll switch over to the just white paper. That way you can read this a lot better. But what's the probability of me drawing any other card? Is it not the complement of
any other one?
Drawing
So
this?
you got 16 out of 52, so just subtract 52 and 16.
Yeah, what's 52 minus 16?
36, right?
I don't know, just double check it.
36
Okay, so we got 36
out of 52.
out of 52. Now, guys, did I reduce my fraction? No, typically we do, but I didn't here. Why? Because I'm about to try and add these up, and I want a common denominator, okay? That's the only reason I'm not reducing the fraction here, okay? So if I want to look at the expected value, we said all you do is take the outcome times its probability for each of these and add them up. So you're doing 3 products and then summing them, okay? So you're going to have 4 over 52 times $10 plus 12 over 52 times $1 minus 36 over 52 times what? Is 0.5 the same as 1/2? Yeah, and I'm going to write as 1/2 because I can actually divide that 2 into 36. That just makes it easy if I'm doing this in my head, okay? Alright, so what's 40? 4 times 10 is 40. over 52 plus 12 over 52 minus, what's half of 36?
40 over 52.
Isn't that 18 over 52? So what's 40 plus 12? That's 52 minus 18.
That's 1 minus. That would be 1. 40 with 12, make 1. And you just subtract that by 18 over 52.
So what do we end up with?
You got 1 minus 18 52. So. Yeah, it's going to be 17 over 26.
So what is that equal to in decimals? Because that's going to be a dollar amount, right?
Yeah. 0.65.
Yeah, 0.65. So you're looking at 65 cents as your outcome, as your expected value for playing that game. Okay? So you might come out ahead, you might not. Okay? Alright, number 12, and again, I told you I'd switch over to the other thingy here. Again, refer to the question on your screen on Google Classroom, because the document is there. And again, I can't stop this in Zoom. That's why I'm going to switch over to write on the white paper. But it says in a group of 4 students, what is the probability that at least 2 have the same birthday month? Okay?
This is number 12.
Yeah. All right. So how do we work that question? This is one of those, guys. Remember we said it's easier to do the complement sometimes? It is. So on number 12, oh, Lord. Number 12 here. If we're looking at the probability that at least 2 have the same birthday month, we can look at the probability that they have a different sign, okay? And by different sign, that means they have a different birthday month. I kind of reworded the question just in terms of birthday month. But if they have a different month for their birthday, then if I can find that probability, then next I can look at the complement of that event, which would mean 2 or more have the same birthday, okay? But it's easier to find this one and then do the complement, okay? So for this one here, ouch. I could have what? You have 4 students total, correct? I can't half read my writing here.
So in a group of 4 students, what's the probability of those 2? You would use like
Alright.
permutation and you put like...
Thank you. I can do permutation. So it's a permutation of what? Because we're looking at...
So you would do like...
We're looking at favorable, correct?
You use 4
Over possible.
times 12, right? 4 permutation 12, right?
Yeah. The permutation of 12 items taken 4 at a time. And then what's the possibility here? Okay. What do I put on the bottom? Dag.
On law, that would be 30. No, 4P12, right? Which reverse it
Okay, 4P12.
on the bottom, right?
I'm not sure about that. I was wondering if I could do the same, if it's at all possible. Okay. Okay, then. That's fine. Yeah, that's what I thought. Nah, that's fine. No, what if there was something on the top of the shell? And she works with so we won't get to talk to people together. So I have 30 people, and then I have a small class for it. So it's like maybe 2, well, probably 9 students now. Maybe. Okay. All right. I appreciate it. Thanks. All right. P12-4. All right, guys. What's the possible outcomes here?
How many outcomes can you have with 12 4? 36. Or in the 48.
We're doing the probability that everyone has a different sign.
Has a different birthday?
Yeah.
Then it's 4 out of 12. It must be 4.
Oh.
Different birthday. Yeah, different.
What's the permutation on the top? If I do 12 math, left arrow 4. I did the wrong thing. 12 math, left arrow 2 and 4. Yeah, that's 11,880. Okay.
I actually found out it was under.
And what's the total possibilities, guys?
You have the 48.
Well, the possibilities is that I would allow repetition, right? So that's really going to be 12 to the 4th power. Okay, so I would count those up using the fundamental counting principle.
So 20,000 instead of 136.
Yeah, so 12 to the 4th power is what? You just told me.
736.
Yeah, 20,736. And then if I reduce that,
41 over 96.
is it 1 or 55 over 96?
41 over 96.
Okay, let me see. 11,880. Yeah, I got 55 over 96. Okay.
It says on here correct answer. 41 over
Yeah, we're not done. We're not done yet. Because remember, we're doing the probability that you have a different sign. And then we're going to say the probability that 2 or more have the same sign is just the complement of this event.
Okay.
So that's going to be 1 minus the probability of a different sign. Okay? Which means 1 minus 55 over 96, which is 96 over 96 minus 55 over 96. And 6 minus 5 is 1, 9 minus 5 is 4, so 41 over 96 would be your probability. Okay?
Can you hold up? I got a copy.
Yeah, I will. But again, that's one of the problems, guys, that it's much easier to find the complement of the event and then to go back and find the actual probability you're looking for. Okay? And again, when you're counting here, that's just permutation of 12 objects taken 4 at a time. And why do we use a permutation there, not a combination?
Because you needed order.
Yeah, order matters there. Okay? Because, yeah, I have 4 people, but the first person, I mean, their birthday could be in March, it could be in December. You know, it doesn't matter. So order is very important on this one. And the possible outcomes, again, you just work that as if I allow for repetition or not. So that's 12 times 12 times 12 times 12 for those 4 people. Okay. And again, the same idea holds from what we saw last week on Friday when we were looking at the other problems. Probability is just favorable outcomes over possible outcomes. And then you just say, okay, how do I count these up for this problem? Okay? And once again, you see we're just using our permutations, our combinations, our fundamental counting principle. Those are tools for doing the counting. Okay? That's what they're there for. All right? Let's see, number 13, you have a binomial probability distribution, has n equals 15 trials with the probability of success on each trial is that.
Well, you have several types of problems you're looking at there. Alright.
Number 13.
Yeah, this is going to 13. So let's look at number 13. And again, I hope you're looking at your copy on Google Classroom while we're doing this. So number 13A, it says find the probability of exactly 10 successes. So we're going to say the probability that X is equal to 10, and that X is the event, okay, of having a success.
You said we didn't have to do it if we got it right. We got it right.
Oh, I know, yeah. If you got it right, you're good. But I know some people did not. So the question is on this one, how do I do this problem? Okay. We said if you're doing exactly a certain number of successes, that you're going to use the binomial PDF on your calculator. Okay. If you're doing X less than or equal to 2 or something like that, then I'm going to use binomial CDF. Okay? So what am I going to do here? We're going to put it on the calculator. And guys, I have some people with headphones in. Okay, we got to be paying attention. All right. So we got binomial PDF. And the first thing on your calculator is how many trials you have. In this case, there's 15 trials. And then you're looking at the probability of success, which in this case is 0.65, which is given. And then the last thing is the number of successes you're examining, in this case 10. Okay? So all you have to, we said that on your
calculator, this is under second vars. So on your calculator here, if you look at this button vars, right above that is distribution. Okay? So on my calculator, if I go to second vars, again, this is your normal distribution up here, but if you scroll down, you get your binomial PDF and binomial CDF. That's A and B. So I can do alpha A, and they tell you if you're on the right one, it's binomial PDF. The number of trials
15.
is 15.
X value is 0.65.
0.65 is your probability of success, and 10 is the number of successes. And then you paste it, and then hit enter, and you get 0.212. So the probability that X is equal to 10 is 0.212. Okay?
I didn't understand how to do B because I forgot how to do failures.
Yeah, we'll look at it. We'll look at it. Okay, B says the probability of, again, this one I told you I would credit back because of the wording. the word 5 should not have been there. It should be the probability of 10 failures.
So that was a typo?
Oh yeah, that was a typo.
That's what was messing me up. I was trying to figure out how to put 5 in there.
Yeah.
I understand that.
Well, I think it was Samuel pointed that out when we were doing the review, or has started reworking the problems, and yeah, that is a definite typo. Okay. The probability of 10 failures. Okay. Guys, I can work this the same way, but remember we said your successes do not have to be a positive thing. Okay? It can be something bad. Can I treat a failure as a success? Yeah, if I change the probability. Okay? So I could use this right here, but switch it and use the complement, which is 1 minus 0.65. Okay? So I can say this is just the same thing, binomial
I tried that.
PDF, 15 trials, but instead of 0.65, which is my probability of success, I'll look at the probability of failure, which is 1 minus 0.65. And then I'm still looking at 10 because I want 10 failures. Okay? So if I put this on the calculator, I guess right here, then I'm going to do second entry. No, I don't want to do that. I could, but let's do second vars and scroll down. I guess it was alpha A. I could have just done that. Hit enter. I have 15 trials, but instead of 0.65, I'm going to do 1 minus 0.65.
That's where I messed up, because I was putting on 5 in the trials.
Yeah. And notice, guys, it does not matter if I put 1 minus 0.65 here. It'll take it. So when it goes to calculate, it's going to do the subtraction, and it'll handle it. Okay? And then I have 10 for the number of failures. And then I'm just going to paste that and hit enter.
0.0.
And so the probability of 10 failures is 0.0096. Okay. All right. Next question.
I don't know why I got this next one.
This is 13C. 13C is what's the probability of at least 14 successes? The probability that X is greater than or equal to 14. Okay? So what's that equal to? Well,
You gotta put that in.
you got to put that in. Okay?
14 successes would be like,
This is actually the probability of what? Of X greater than or equal to 14 and less than or equal to 15. Okay? That's another way to write it. Okay? But we said if it's greater than or equal to 14, that's the same as the probability that X is equal to 14 plus the probability that X is equal to 15. Okay? So I take these calculations of exactly and I add them together. Okay? So I can work this problem using binomial PDF if I want. Okay? All right.
how do I put that in the calculator?
All right. Well, one way is to do this.
So
I can do second vars. Alpha A is the binomial PDF. Again, we still have 15 trials.
Yeah.
My success is 0.65, so I'm going to change that back. And I want to do the binomial PDF for 14 successes. Okay?
That's not messed up.
And then I'm hit enter.
I put the successes where the trial was supposed to be.
Yeah. And then I'm going to do plus, because I'm going to add to that the probability of 15 successes. So I can just say plus second bars. I don't want normal, I'm going to do alpha A. So I got 15.65, and here I'm going to put 15 and paste that. And then I'm going to hit enter.
Yeah, do that. Enter plus.
And you get 0.0142.
What'd you put? What'd you do with the trials the second time? I didn't see.
The trials is still 15.
No, what'd you do though? Like, you just changed X value to 15, right?
Yeah. Because you're just simply adding these two together, and then you get 0.0142.
I just want to see how to do it. That's your answer?
That's my answer.
We got some more problems.
All right, guys, we got two more. Number 14. Okay, number 14 says the probability of event equals
1/5. Okay. What is the probability of the complement of the event? The probability of not E. Okay. Again, how is the complement defined? We said that's 1 minus the probability of E. Okay? So the probability of the event not occurring is the same thing as 1 minus the probability that the event does occur. Okay? And that's just 1 minus what?
1. Isn't it? No.
Is 1/5. So the probability is going to be 4/5. Why? Because 1 is 5 over 5.
And then
Minus 1 over 5 is just 4 over 5. Okay?
that one was the easiest one.
I had it the first time, I thought I was wrong with that.
No, that, guys, is just simply the definition of the complement of the event. That's all that was. Okay? All right, 15. Let's switch papers. Number 15. All right, number 15 says a spinner has 5 colors: red, orange, yellow, green, and blue, with each equally likely to be selected. That means it's a fair spinner. Okay? The probability of landing on each of the colors is exactly the same. Okay? It says if the spinner is spun and a coin is tossed, what is the probability of getting the color red and tails? Okay?
Yeah, how do you do this one?
Well, are both the events independent of each other? Does tossing the coin have anything to do with the spinner?
Nope.
No. So we know that in the end we're going to take the probability of each,
And add them.
not add them,
Oh, that's right.
we're going to multiply them.
That's right. That's okay.
Yep. So if the events are independent of each other, I multiply the probabilities. Okay? So all you have to do here is say, what's the probability of getting red on the spinner?
1/5.
Is 1/5. Why? Because there's 5 colors. They're all equally likely to be selected. So yes, I could draw a spinner. I could find what's the angle measure and then say this number of degrees out of 360, but guess what? It's going to reduce down to 1/5. So there's no point in doing that. Okay? Why? Because all the probabilities of getting each of those colors have to add up to 1. Okay? And 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5 is equal to 1. Okay? So we know 1/5 has to be correct. Okay? The probability of tails is what?
1/2.
Just 1/2. So the probability that I would get red and tails
1/2 times 1/5.
is just the probability of red times the probability of tails, which is 1/5 times 1/2, which is 1/10, which is 0.10.
That's where I messed up. I added them, and I got 2 7.
Okay. And I think this one you could have just entered 1/10. Okay.
Yeah.
And you would have been fine. That's really weird. On our clock up there.
We got the thing on it. It's
Yeah.
They're all done.
It must be working on it or something.
It's been on every clock almost.
Yeah.
I have a question.
Yes, sir.
You said, not the probability of getting a red and it tails. What would we do then?
If they said the probability of not getting red and tails, I would have found the probability that we just did, and then I would have said 1 minus that event, the probability. So I would have said 1 minus 1/10, which would have been 9/10.
Are you gonna take this up?
So it's more likely I'm not going to get that outcome because there's so many other choices, right? So
Are you gonna take these up?
no. You have a cumulative test tomorrow.
Is this the same stuff as this?
So yeah, the stuff will be
Or
on it.
cumulative,
Yeah.
that's everything on here, right?
That's everything. Yeah.
I gotta be on a
So
report card?
you have to study, okay?
That's not gonna be on a report card, is it?
It probably will be. Yeah.
So aren't the
Okay.
races due like Wednesday?
I'm pretty sure it will be actually. Which means, guys, you need to show up for the test tomorrow. Okay?
Can I bring that sheet by to you second period?
Is that clear, everybody? You need to make sure you're here for the test tomorrow.
In that second period.
What?
That sheet here. I have it, but like it's
That's Jabari Tatum's sheet.
I know. Can I bring mine to you second period?
Yeah. Yeah, that's fine. All right, that's everything for you. Did y'all have any questions?
From what we were doing last week. Can we go over some stuff we did at the end of the year? 'Cause I kinda forgot it. Test on that more?
We can. Can I go over normal distribution real quick? Just very, very quickly. Okay, the things that are key for you to know for normal distribution are this right here. Okay? It looks like a bell curve. Okay, this is normal distribution. Okay? This point right here in the middle,
That's 60 something.
that is your mean, that's your median, and that's your mode. Because in a normal distribution, all three of these are sitting at the same point. Okay? As soon as that data gets skewed, the mean, median, mode no longer line up. Okay? Yes. Yeah, I need it. Okay? Now guys, there's breakdown. Okay? Typically, on a normal distribution, if you're looking at z-scores, z-scores is your standard deviation, okay? And your mean is typically represented with a mu, but for us on the calculator, it's x bar, okay? So when you do one variable stats, you get x bar as the very first number, that's the mean value, okay? Your standard deviation is sitting here, so that's sigma and negative sigma. And then over here I have another one which is 2 sigma and negative 2 sigma. And I can't write that good, y'all. And then over here again, I have 3 sigma and negative 3 sigma. Okay?
Is that sigma or 6?
It's a sigma. It's just, it don't look like it. This right here is sigma. Okay? So sigma is the Greek letter, and you'll see that on your calculator as sigma x.
How do you get to that again?
That is your standard deviation. Okay? So on your calculator, that is the population standard deviation. SX is your sample standard deviation. But this is the one we want to use. Now, some of the key things we said were how this data is distributed, and within these 2 values, within 1 standard deviation of the mean, how much of your data is sitting there. Come on, y'all. It's approximately, is it 68%? Yeah. And then between 2 standard deviations, that's approximately 95%. And then between 3 standard deviations, yeah, 99.7. So this is 99.7%. You have to memorize those, okay? You are expected to know those. These break down, guys. Half of 68 is what? 34. So there's 34% here. There's 34% here, okay? So I can break these down. You need to know how to break those down. Because if I'm asking you, okay, what's the probability that, or the percent of scores that sit, and a percent can be a probability, because that's exactly what this is basically a probability distribution. If I want to know between these 2 values, I simply add up the area under the curve, which is this percent plus that percent plus that percent. That's all you're doing is adding area under the curve, okay? So when you do a normal CDF, that's exactly what's happening, is adding up that area, okay? Now, we said you could do it on the calculator. You can do it by hand if you know the breakdown. But if they ask me something right here to over here, guess what? That's going to be calculator work. If it's just on these standard deviation breakpoints, I can do that knowing these percentages, okay? But as soon as they ask me anything other than that, I'd go to my calculator, okay? Not saying you can't go to the calculator anyways, because it'll still do the problem. You just have to tell it what it needs to know. You know, what's my mean? What's my standard deviation? What 2 values are you looking in between? That type of thing. We said also 50% of your data, this curve is symmetrical. 50% sits to the right, 50% sits to the left. Okay? That's just how it is. Okay? And all of this adds up to 1. If I were to sum up all of this, it adds to 1. Okay? All right. How do I do a z-score?
No, I did the other day.
It's just x minus mu over sigma, which is basically x minus x bar over sigma. Okay? So it's the difference between the value of the data point minus the mean value divided by the standard deviations, and all that z-score is telling you is the number of standard deviations from the mean. And it can be positive or negative. Positive sits to the right of the mean, negative sits to the left of the mean. That's all it is, okay? Is everyone good on that? Okay. How can I use z-scores? The other day we said, hey, if I define a new mean and a new standard deviation, that's the same as sliding that bell curve to the right, okay? All I had to do was redefine where I want my mean and where I want the standard deviation, okay? Because if that standard deviation was more than what I have room for, I have to change it, okay? So I think I was talking, maybe it was with Justin the other day, to slide that bell curve to the right, all I have to do is say, hey, typically we don't give students lower than a 50 on a report card, okay? How about I make that test score between 50 and 100, which puts the mean value where? Where does it put the mean value?
Higher.
Higher, which is going to be 75. And then how do I break down the standard deviation? Well, how many breakpoints do I have here? 1, 2, 3, 4, 5, 6.
Yeah.
So why not divide that 50 to 100 by 6 and define my curve standard deviation? And my curve mean is 75. And then all I have to do is take the z-score and back out the new curve test grade. Okay? Does that make sense? So we can use that normal distribution, and it allows me to keep the same relative distribution that the class had, but I slide it to the right.
That's
Okay.
how you do your curves for us.
Yeah. Yeah. Maybe on Wednesday.
How I do that on a spreadsheet. Because I think you need to know that when you're looking at data. I want you to know how to do the normal distribution on a spreadsheet as well. Okay? Because part of what we're supposed to learn in this class is not just the standards, but also your 21st century skills. You know, when you go into the workplace, can you analyze data in a spreadsheet? You need to know that, okay? Like I said, the most people that are going to be doing this normal distribution stuff, it could be people working in a factory and you're looking at machine equipment. When you start getting defects within one standard deviation of the mean value, it might be fine. But as soon as you start hitting 2 and 3 standard deviations, guess what? Like mistakes that big, you need to have your machine serviced, okay? So these curves are used to make decisions in the workplace, especially when it comes to machine maintenance. Now, if you're a boss, Samuel, your boss one day, let's say I have I'm looking at times that people show up, okay? If people are late a little bit, I don't want to ride their case, maybe. But if they start being late outside of 2, 3 standard deviations, that's when you got to have a sit-down chat with them, okay? But I could look at the time of arrival and say, well, on the mean, people are, if I use my one variable stat says the number of minutes past their scheduled time of arrival, then maybe within a certain amount of time it's okay, unless that mean value is pretty high and you're like, I don't like that and I'll talk to everybody. But if someone's really outside that higher standard deviation, you may want to have a sit-down chat with them and say, look, this is unacceptable and they need to change their behavior, okay? So there's lots of ways you can use this curve, okay? And it's going to depend on you, what position you're in and whatnot. It could be that you go into a workplace and your boss isn't doing this, but because you paid attention in AFM class, you can say, hey, this thing we studied in school will really help you out. Then you get kudos and you might even get a raise because you're helping your boss do their job better, okay? Do you know what I'm saying? So everything you go in knowing, it's going to help you out. But this normal distribution is very, very important, okay? It'll show up in a lot of places, all right? Any questions on that? Okay. I'm sorry, y'all.
How many questions are you going to make the test tomorrow?
I'm not sure. I've already got it mostly made out, but I have to put the more recent stuff on there. But I need to look back over it later today, so we'll see. All right. You guys wanted to look at some of our earlier stuff. Some of the things we did start with were Arithmetic Series and geometric series, sequences, that type thing.
That stuff's pretty easy.
Yeah, that stuff's pretty easy, but again, do you have formula sheets for that? Yeah, you have to know that when you do those problems, you do get a formula sheet for those. So I don't have to memorize the sum of a geometric sequence or anything like that. I just need to know, hey, I can go to the formula sheet.
Can we go for arithmetic series?
Yeah, arithmetic series.
I understand. Sequences is the easy stuff.
Okay, arithmetic series, I could have something like a negative 8, a negative 4, a 0, a 4, a 8, a 12, dot, 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 dot. And what's my common difference? Because we always have a common difference. We also have a first term.
This one you're increasing by 4.
I'm increasing by 4. So I start at negative 8. I'm increasing by plus 4. So I'm actually adding 4. That's how I progress. That tells me it's arithmetic. If I have a common difference, then I am looking at an arithmetic series. So if I have to identify it, that's what I'm looking for, a common difference. If it's geometric, then I may have something like half of negative 8 is negative 4, half of negative 4 is negative 2, half of negative 2 is negative 1, half of negative 1 is negative 1/2. And it progresses. Does it ever reach 0?
Yeah, it's 0 in the middle right there.
Nope.
It's right there.
Not if it's geometric. Not if it's geometric. Which is actually a very interesting problem, guys. Why? Because if I start at 1 and I keep doing a half, I never reach 0. It gets smaller and smaller and smaller, but never hits 0.
You can do a geometric too after we finish this one.
Yeah. So, guys, first of all, you need to know, how do I do the explicit formula? And how do we do that? That's using a sub n equals a sub 1 plus d times n minus 1. Okay? Or n minus 1 times d. Okay? So you're looking at a sub n is equal to a sub 1 is a negative 8 plus your d, which is a 4, times n minus 1. And then all I have to do is simplify this. So negative 8 plus 4n minus 4. So you're doing distributive property, 4 times n and 4 times negative 1. And then you get negative 8 plus 4n minus 4. And why did I rewrite that? I'm not thinking. What's negative 8 minus 4?
Oh, negative 12.
Yeah, so I get 4n minus 12. I'm going to write the negative 12 second because I'd like to keep that negative sign on the inside since that 4 is positive. That way I don't ever lose the negative sign in my equal sign. Okay? And then that's a sub n. Okay? So I can calculate any term in this
So that's that equation.
sequence if I simply say what term number am I looking at. If it were a sub 100, I'd plug in n equal to 100 and get 400 minus 12, whatever. And whatever that ends up being, which is what? Is it 388? 400 minus 12? I think so. Okay, the other type formula was recursive, right? And if you remember recursive formula was simply writing the next term in terms of the previous term. This is writing the term in terms of the term number. That's your explicit formula. But recursive, I would have a sub n plus 1 is equal to a sub n. That's my previous term. That's my next term. But what am I doing to the previous term to get to the next term?
You're adding 1.
I add what?
So it says you're adding 1, right?
I'm not adding 1. I'm adding 1 there to get to the next term. But what do I do to the previous term itself? How do I go from negative 4 to 0?
You add 4.
I add 4. So that's all I'm going to write is plus 4. And then I'm done. Okay? That's it. So recursive formula is simply A sub n plus 1 equals A sub n plus the common difference.
You have to
And
put
that's
one,
it.
you have to put 1 every time though? Like a sub n plus 1, that's going to be there every time?
Yeah. The other way I could write that is A sub n equals A sub n minus 1
But
plus 4.
a sub n plus 1.
That's just a subscript.
A sub n plus 1 is a sub n.
Yeah, but that's like my next term or previous
Okay.
term. And again, the subscript, that's just a shift in the C. So it doesn't matter how it's written. Okay? All right, but that's your arithmetic series. Yeah.
Can you go over something with probability? I have a hard time
What do you mean with probability?
with anything.
Because that's what we were just going over on the Unit 2 test. So I will go back and look at what we did on that.
Geometric.
Okay. All right.
Do a geometric series.
But I'm telling you, probability is just favorable outcome over possible outcomes, and add up each of those and do the ratio. You know. But always ask yourself on each situation, what's my favorable outcomes, what's my possible outcomes, and then divide the two. Okay?
Geometric series, is it the same? Like formulas?
It's different. I don't know why I said series a while ago. We're actually looking at a sequence. Okay?
Yeah, that's what I thought.
So yeah, I messed up the terminology some, but whatever. Series is when I'm adding things up.
Yes, the series
Okay.
is the easy part. It's like the sequences is harder.
Yeah. So if I look at like what we did a while ago, let's say I had a 1, a 2, a 4, an 8, a 16, a 32. Okay.
Multiplying by 2.
We're multiplying by 2. So I have A sub 1 is equal to 1, but my common ratio is 2. Okay.
I thought it would be times 2.
It is times 2,
Or you're just going to write 2.
but the ratio itself is a 2. And then the term A sub n is just A sub 1 times r to the n minus 1. Okay? So if I want to do the explicit formula, then I'm going to have A sub n is equal to 1 times my r to the n minus 1. Okay? And guys, if you look at this right here, I can break this apart using my rules for exponents. So this is just 2 to the n times 2 to the negative 1. 2 to the negative 1 is just 1/2. So I really get 2 to the n over 2 is A sub n. Okay? So that's my explicit formula. If I plug in a 1, then I get my first term is equal to 1. If I plug in a 2, I get 2 squared over 2, which is just 2. If I plug in a 3, I get 8 over 2, which is 4. So once you get your explicit formula, make sure you check it. Plug in the values of n equal 1, 2, 3, and verify that you're getting the correct values. Okay? The recursive formula is just as easy as the other one for arithmetic.
Are you able to use notes and test?
A sub n plus 1 is equal to what?
A sub n what? Plus 1?
For the recursive on geometric.
A sub n plus 1, 2 plus 1?
It's not 2 plus 1.
It'd be a sub n plus 2. Or something like that, right?
It's A sub n, and what am I doing to each term to get to the next one?
I multiply by 2.
So I'm going to say times 2,
So
which is just 2 times A sub n. So A sub n plus 1 equals 2 times A sub n, which is basically just r times A sub n. Okay? That's what it is. So guys, the recursive formula, there is no memorizing it. It's just what am I doing to the term to get to the next term? Just ask yourself that question. Arithmetic, I'm adding a number. Geometric, I'm multiplying by a number, and I just write down what that is. And then you're done. Okay? Alright. Alright, does anyone have any other questions? Alright. Remember, if I'm doing a sum, either finite or infinite, those formulas are on the formula sheet.
Is there anything that specifically need to go over tomorrow?
Hold on one second. Guys, the formulas are on the formula sheet. Your goal, though, is to identify what's the common ratio, what's the first term, and substitute into the formula and go from there. Okay? Does that make sense? Okay. And you had a question, and then you had a question.
Is there anything we need to study specifically, like, that's going to be like one?
I would just go back through the previous test and look at what you missed.
Like what we
Okay?
did.
That's where I would focus. Now review the other stuff, just say, oh yeah, we did that, oh yeah, we did that. But spend your time on what you were missing. Okay? And again, we'll have stuff that's more recent, so that shouldn't be intensive study on
Like
that.
stuff that wasn't even on the last test, like that.
Yeah, like normal distribution,
Yeah.
the one variable stats,
Z-score.
box and whisker plots, things like that. Okay?
Are we going to use notes on test tomorrow?
I doubt it. I doubt it. All right, guys. Anything else? You had Jabari a question. You need your login. Okay. Let me deal with that. Hold on. Let me stop this.